Hello, Algebra. Welcome to Inequalities. Our learning target for today is involve three separate tasks that we do with inequalities. They are that you will be able to write inequalities, graph inequalities, and solve inequalities. The subtitle that you see there, adding and subtracting, it really only affects when we are solving. It won't have anything to do with writing or graphing. So let's jump straight into this. Many real life situations involve minimum requirements or maximum requirements rather than just being equal to a certain number. And so that's what we use inequalities for in order to model these situations. I'm sure you've seen inequalities before. So we've got the four symbols for inequalities and the equal sign I threw on here also. So you got less than in yellow, the green one greater than, blue is less than or equal to, and the magenta one greater than or equal to. So let's look at a couple of examples. The voting age in our country is 18. Right? So we could say, well, in order to vote, your age has to be 18. But that's not entirely true because it's not only people who are 18 that get to vote, right? And so we would not actually want to use an equation in this situation. But we also wouldn't want to have to list every single possible age. Age equals 18, age equals 19, age equals 20, 21, 22, and so on. That would take forever. And so we might say, well, look, your age has to be greater than 18. But that's not quite right either, because this says that your age has to be not 18, but bigger. And so the best solution here would be to say that your age needs to be greater than or equal to 18. Here's another example. Let's think about ages for this also. What's the oldest you could be and still be a teenager? Well, you might say 19 is the oldest age you could be and still be a teenager, so your age would have to be less than or equal to 19, which is a good idea. But then what if someone was 19 years, 9 months, and 22 days? That comes out to 19.8. And 19.8 is not actually less than or equal to 19, but this person would still be a teenager. So the best way to express this would actually be to say that your age has to be less than 20. So we can use that 20 as a reference point, but it's not actually included as part of our solution. And so there's this idea that goes along with inequalities about using something as a reference point or something to compare against, but not actually including that, like in this case, with age having to be less than 20. But in the voting age example, the one that we liked best here at the end was inclusive. We wanted to include 18 as part of the voting age, and that is why this one did not work. So that idea about things being included or not included when we're using it as our comparison or our reference point, that's also going to show up when we're graphing. So let's start at the top. When we're graphing, we're going to learn how to graph on a number line. Later, we'll learn how to graph on an XY coordinate plane, but for now, we'll just use a number line. So there are two groups of symbols, the greater than or equal to, less than or equal to, and the equal sign for that matter, if it shows up. We use what's called a closed dot, which is inclusive. That means the place where we put the dot on the number line, that is included as part of our solution, like the age 18 when we're talking about voting. If you're 18, you can vote. We include that as part of the solution. The green highlighted symbols, less than or greater than, those use what's called an open dot. It's exclusive. It's like a hollow dot or just the outline of a circle. And that is like what we used when we described the age of the oldest age you could be as a teenager. So we use 20 as the comparison, but 20 is not a teenager. And so that's excluded, right? 20 is what is written as part of the number sentence, but it is not part of the solution. Okay, so when we're shading inequalities, there are two parts we have to pay attention to. First, the dot, and then the next bullet point tells us we shade along the number line. Since inequalities refer to not just one number, but an infinite number of numbers, instead of putting all those dots every place, like for voting age, at 18 and at 19 and at 20 and so on, all the way up to 100 or whatever, we just use shading. It makes this job a lot easier. So here's an example with this number sentence: x is less than 4. Okay, well, since that number sentence uses a less than symbol, we're going to use an open dot. So on the number line, I'm going to go to 4, and I'm going to place an open dot right here, or just a circle around that spot on the number line. And then I'm going to shade the part of the number line which makes the number line true. So it says that x could be anything less than 4. And numbers which are less than 4 are going to be on the left side of that dot. So from the dot, I'm just going to shade across the end of the number line, put an arrow to indicate that shading actually keeps going forever, just like the number line, but I don't have to keep drawing it forever. Okay, on a quick aside, over here at the very right-hand side, I put some extra symbols. Some of you may have seen these symbols used, particularly if you have learned math in a different country. So these symbols do the same job, and they're symbols that we'll learn about later on in your math career as part of a thing called interval notation. But if you've seen these symbols before, they do the exact same job. They have the same meaning as the closed dot. It's the square brackets. They mean the same thing. And these round brackets mean the same thing as this open dot. So just different symbols. We'll learn about these other ones later. Okay, so let's look at a couple of examples. Solve the inequality, and then we'll graph our solution. So here, x plus 1 is less than 4. The principles of solving are exactly the same for inequalities as what they were for equations. So I'm going to do the opposite operation to try to get that x by itself. I have to do the same thing on both sides of that symbol to keep it balanced. Even though it's not equals, one side is more and one side is less. And if I were not to do the same thing on both sides, then that would shift, and maybe the one side would no longer be more than the other. So I have to do the same thing on both sides to preserve the truth of the number sentence. Okay, so x is less than 3. And when I go to the number line to graph that, I'm going to use a open dot on the 3. And less than always means to go to the left on the number line. So I'm going to shade. Some people like to color that in really darkly and make it look really pretty, and that's awesome. It's not needed. Okay, x minus 2 is greater than or equal to 6. So again, I'm going to do the opposite operation. So I'm going to add this time. These 2's will cancel. X comes down. That symbol greater than or equal to comes down, and 6 plus 2 gives me 8. And my number line's just down here off the bottom of the screen. So to graph that, I'm going to go on the number line to 8, put a closed dot at the 8. And since x is greater than or equal to 8, I'm going to start at that dot and shade to the right where numbers would be greater than 8. And we'll just look at one more here. X minus 3 is less than or equal to negative 8. The opposite operation would be adding, so I'm going to add 3 on both sides. X will come down. This inequality symbol comes down. Negative 8 plus 3 is going to give me negative 5. And then on the number line, negative 5, this will be a closed dot since this symbol has or equal to as part of the symbol, as part of the name. And since x is less than or equal to negative 5, I will shade to the left from that dot.